a short presentation and introduction to S100, taking a short peek at the history behind S100 and the drivers for development. We'll also have a look at the timeline and some of the expected benefits of S100. Yeah, introduction already done. So if we look at the timeline, we can see that we go quite a long time backwards in time, all the way back to 1982, actually, when the Committee on Exchange of Digital Data was established. So this was kind of the predecessor before eventually S57 emerged in 1992. And the S57 development, the electronic navigational chart, it's still going on, but we can see how it developed throughout the years from 92 until the year 2000. And then after the year 2000, when the development of S57 moved further on towards an edition 4 of S57, S100 was eventually born as a result of that development. S100 has been developed now for 14 years, since 2010. It's been released several versions. What is considered to be the operational version, edition 5, was released in 2022. Last year, there came also an upgraded version 5.1, and this year we are waiting for the IHO member state approval of edition 5.2 of S100. So what were or are the drivers behind the development of S100? I would say that originally it stems from the work with S57 and the limitations we saw lies within the traditional electronic navigational chart and standard S57. It's a frozen standard. It's quite inflexible to maintain. Also, the object and attribute catalogs are integrated parts of S57, which provides very little flexibility. It also does not support what was expected and is expected to be the future requirements for more dynamic information types like complex time-varying information, gridded bathymetry, surface current information, water level data, and so on. Even though the intention of S57 initially may have a broader scope than only the electronic navigational chart, history has shown us that mainly it's become synonymous with the electronic navigational chart. So it's a limited standard, only being used for ENCs to be used in end user systems like ECDIS. Also, S57 has a very close connection between the data model and the encapsulation or the format itself, which is not the case for S100, where you have a much bigger separation between the data model and different encoding formats. We can also say that S100 is technology driven, at least for the latest couple of years. The advent of autonomous navigation has also started to influence more and more the development of S100. S100 also provides a better cybersecurity scheme than we are operating today in the old S57, S63 era. And of course, the interoperability advantages, the ability to combine different types of information, make it graphically visible together in an end user system. It's also something that comes with the S100. A lot of work has also been done on service on the metadata part. So it's possible to provide a lot more data discovery type of information, which is also good for creating good and efficient services for provision of S100 data. And we can see also now when in the recent years, some test beds starting to test out S100 are starting also to demonstrate that there lies good economical, environmental, and navigational safety benefits in the use of S100 data. And here you can see an example from a test bed we ran in Norway, where we created an underkeel clearance management product, which made us able to take a vessel through a quite narrow, challenging area, and as such, reducing the sailing distance. And as you can see by this small calculation, adding up this voyage to be done 5 times a month over a year gives quite a significant reduction in the emissions. So S100 is built upon the ISO 19100 framework. It's a framework for geographical information provided by ISO. And many different of the components from the 19100 series is being used as the fundament for building the S100 data framework. Important part of the S100 framework is the geospatial information registry. This is an online registry containing several registers for different type of information. It could be data producer codes, product specifications, it can be concept registers, descriptions of all type of concepts related to S100 and the maritime domain, objects, attributes. It contains infrastructure tools for the maintenance and development of S100, and also other components. So it's a very important piece of the S100 framework. Currently, in the latest version of S100 edition 5.2, we now have 18 parts, and it's quite a large document consisting of approximately, I think, 900 pages now. Here we can see illustration of the S100 world, and contains a lot of information. It's not possible to talk through everything that's in this figure today, but basically what we see are a lot of different elements that we find in the maritime domain. Those elements have been transferred into S100 compatible product specifications. So for example, here we find the S101 ENC, we have the S102 gridded bathymetry, the surface current, the water levels. And we can also see that we have route information, weather and wave hazards, ice information. So some of this information lies with the International Hydrographic Organization, and the product specifications are kind of created by their technical working groups. But also other international organizations have adopted the S100 framework and are now creating product specifications based on the framework. And these are listed here at the bottom of the figure, where we can see NATO, IAC, WMO, Inland ENCs, IOC, and EALA being listed as other organizations also working with the S100 framework. Today's topic, or next presentation's topic, will be S131, the Marine Harbor Infrastructure, which you can see also reflected here in the figure. Taking a look at the top, we can see that there is a critical framework defined. These are the critical components needed for making S100 become a reality, and S100 itself is, of course, one of these elements. Then the IHO has developed an implementation strategy where the implementation of these products are planned for 2 phases, where we have the route monitoring products here in phase 1, and in phase 2 we have route planning products. This brings us over to a timeline provided by the IHO. And again, in this timeline on the top here, we can see the critical components. Then we have the phase 1 and the phase 2. There's a lot of information here as well, and I won't dive into the details, but what's important to note, I think, is for the critical and phase 1 product specifications, we are now starting to move into the approval and implementation phase for all of those components to become operational. This means that when we go into 2025 next year and towards 2026, it should be possible to see operational data emerging from these product specifications. As you can see, S131 is here in the phase 2, and it has a longer time frame for being developed towards becoming operational. So currently here, the development of the data model and the product specification is moving towards edition 2, and before it will also go into an approval and implementation phase eventually. I have listed quite a lot of S100 benefits in my presentation, and I don't think I will go through these in detail, but they are here for you to have a further look at later if you so wish. I can mention some of the ECDIS specific benefits. You have the concept of multiple product portrayal and interoperability, which would provide good information for the end user, getting information from different sources about different types of information and then merge this together in an end user system. We are also expecting that there will eventually be an improved peak report functionality within the S100 ECDIS, and currently in the development of the S101, the electronic navigational chart based on the S100 framework. We are also working on an improved check update functionality. Should make it easier for the mariner to actually understand what has been updated when he received new updated information in his electronic charts. We also believe there will be enhanced portrayal and use of quality information in the S100 ECDIS, and it also facilitates for automated updating of portrayal and feature catalogs. Meaning with S100 comes machine readable catalogs, feature catalogs, portrayal catalogs, interoperability catalogs that will make the time it takes from a change in the data model and in the product specification until it can actually be adopted and this new information can be read on board in the end user system. This time should be significantly reduced compared to how it is today with the development of S57. It will also be possible to have a multiple product installation from a single source, facilitating the use of the exchange catalog, exchange set structure described in S100, where you can package different types of S100 information together in one data package for delivery to the end user. And also the reduction of alarms has been also a quite important topic in the development of the next generation of the ENCs. A few words also on the water level adjustment, which I think will be one of the main selling points perhaps for the S100 ECDIS. This is where we move from having the single layer of official S57 ENC data, replace this by using multiple interacting layers of navigational data. So you can then create safety contours and do calculations based on the gridded bathymetry, the S102. And this can also be adjusted for water level information. So with the electronic navigational chart, the S101, and the gridded bathymetry, the S102, and the water level information that is in S104, this in combination will give a fundamental depth against which the underkill clearance and vertical clearance then can be measured and managed in the S100 ECDIS. So just to demonstrate how it's supposed to work, if we first focus on the left side of this slide, we can see here a typical S102 product where we have this gridded product with a depth value inside each of the grid cells. And this information will be suppressing the depth area information that you have in the electronic navigational chart in the S101 itself. Then this information can further be adjusted towards the water level information. So what you see happens here is that the gridded bathymetry information is adjusted when we put on the water level information and increases the depth by 1 decimeter. And then you can do user selected safety contour on the grid, like illustrated here. The visualization here on the right shows us how the availability of navigable available water is changing throughout the period here of 21 hours. And the safety contour in this example here is set to 7 meters. So major benefits of S100, I would say, is water level adjustment, of course, and you also have the ability for the user to select the safety contour and the generation of this contour based on the gridded information. Also, having the ability to combine more information now from different sources and combine them into a harmonized display for the end user will probably also help improving decision making and as such also improve the safety of navigation. And with products like you can see on the top right there, which is an underkeel clearance management product, it's also possible to gain much more out of a vessel. You increases the navigational space and you can also do more optimized loading. It will probably also be beneficial when it comes to route optimization, just-in-time arrival, as mentioned by Alv here in the introduction. And of course, the added cyber security element that S100 defines in S100 Part 15. It's also a good benefit to note. And again, I would just like to mention that autonomous navigation over the last couple of years now really also has started to influence the development of S100, where the IHO has established project team which has started doing gap analysis to see where can S100 and where can the different derived product specifications be further improved to support the autonomous future as well. On the right-hand side here, you can also see a couple of pictures from test beds we have had where we actually have been out doing real live operations here with two of the world's largest crane vessels, where you can see by using S100 data, we were able to get these very, very large construction through very narrow and congested areas. So that's it from me. I just added a few resources for you here. IHO information on S100 on the top there, bit on the IHO S100 implementation strategy that could be of interest. And also Electronic Charge Center and Primar has S100 relevant information as well on their websites. So thank you very much.
Thank you so much, Svein, for the introduction. We will now hear from Mikus Ranka, who will delve into the S131 specifications. Mikus has been in the nautical chart production since 2007. From 2008, he led the nautical charting division in the Maritime Administration of Latvia Hydrographic Service, where he oversaw all navigational nautical publication production. He started at ECC in 2022 as Senior Geodata Consultant, where he covers data validation, standardization, and various projects. Mikus has been involved in various IHO standardization working groups since 2008 on behalf of his employing institutions. Go ahead, please, Mikus.
Thank you, Al, for introduction. So I'll share the screen. Hopefully it's on the screen now. So yes, I'll talk about this S131 data model and potential for encoding of relevant port information. I'll start a little bit with the background, then the product specification, show a little bit of the data model, what it is, and then talk about some test beds already out there. Introduction, yes, done. Why S131? So as Alv already showed, this is the project's main thing, and we think that with S131, it quite nicely helps to solve the project goals and some expected impact, or improving some expected impacts of the project. One mention here is that from the port information manual, nautical data, is that it says that only official nautical publications fulfill solid carriage requirements, and that is the issue today, that a lot of mariners face, that the information, it's doubtful to use it, or it's in PPU units, it's more kind of up to date but unofficial. So it is confronting to use this information when it's not official. And one thing that this was recognized also in IHO, and as Svein told, the S100 framework was developed, and based on that, also the S131 product specification was started to be developed. There's under the IHO, there's a Nautical Information Provision Working Group, which is the one who is developing this product specification. It started in 2005, and in 2020, so it was officially started to develop this product specification. And the participants of that is IHO member states, industry, Port of Rotterdam, and academia. At the moment, the published version is 1.0, and to be clear, so the 1.0 means that it is good for testing, and but it's not official or for implementation or use before it's 2.0. So it is, as Svein showed also in S100 implementation framework. Then this is a part of wave 2 product specification, and it is still possibility to influence this product specifications development and testing. What is S131? It's a S100 standards-based product specification. I think it's important to recognize there's all these S100s, 200, 400, 500. they all are product specifications, which are based on a concrete S100 standards version. At the moment, the 5.2 of S100 will be the one which will be operational, and the 2.0 of product specifications, with one exclusion of 3.0 for S102 product specification, which was shown by Sven Schaulen. So they will be then the operational. And the main thing is that the content definition and the presentation is the flexibility. That is that machine readable part of that system. So everyone implements S100, which is empty. It's a shell carrying or enabling all the product specifications which are developed on top of that. And he also mentioned that IHO has the tools to actually help to develop those product specifications. So you can actually develop a new product specification based on S100 using the IHO tools. And all this is registered in a registry, as he also showed. And so this is basically like a Danish legal system where you can build on the blocks. And so if the block is registered, you can reuse it. That's why the S101 and S131, S140, S421, and so on, they are they can interact within themselves because they are based on the same rule sets. It is the most kind of simple in a way that in an interaction way, it's a simple product specification because it is as an overlay. As Sven Schaulen showed, that the S104 can impact S102 and S102 can impact S101. So there are specific rules again defined in S98, which is interoperability standard, how this in EGDIS will interact or should interact. But the S131 is intended to be just an overlay, so it doesn't interact with the base navigational dataset, just an overlay information. But the good thing is that if the S100 is implemented and also in the PPU units or like harbor data, whatever, it is if it's based on S100, it can read and use and show the data based on the presentation catalog and the feature catalog. It's a vector product, so it's not a raster, it's vector product with a geographical information, so the layouts and the attached information to it. It allows to encode the layout of ports and availability of port services, facilities, locations, service areas, service offered, and contact details, and so on and so forth. It's intended to be as a supplement to ENC, so as an overlay. It is built taking into account the port information manual, so it was a good start to understand what the needs could be for that kind of product specification in IHO. But again, because it's in 1.0 and testing and implementation and still development, if there is a necessity for this group or for this standard that it takes it into account and relies on it, at the moment it is possible to impact it in a quite high level before it actually reaches operational state. And yes, as I said, it is flexible in a way that it's not only intended to be used in EGDIS, but also it can be used in any companies, in any software, because it's built on ISO standards rather than it was previously very, very specific S7. So, and then the relevant data, harbor infrastructure, facilities, services, and regulations is also in a scope of S131. Information, so again, when it comes into what it should be in S131 is the sailing directions, pilots, coast almanacs from hydrographic offices. So that's why it is a concern of hydrographic office as well as an official nautical publication issuer. So then they must work together with the ports in that sense. So, but they can be a very good start where the S131 could be started because that's official information what's published. And also it's based on in a port manual. It's mentioned about birth-to-birth navigation, IMO resolution, and the recommended contents in port information books. It is really scalable. So how it's built, it is that it is even enough with just one entry, just one polygon, and you can describe if that's the port, that's the port. And it can describe also very, very complex ports and mega ports. So with the same ease. It's just more information, but it's exactly the same. So it is standardized. And yeah, improve the information exchange because now it's a standard. It's one implementation and have a product specification. From this, so we can say the nautical data that holds this information in S131. We can say also that there can be some, well, starting and completion times, not necessarily what the ship is planning, but what the actual times are available in the port or for port services. So that's that information also in S131, and all the IMO port facility numbers or port numbers, they all are can be confirmed when you look at the data or reuse the data in your reports and so on for planning. Data modeling, maybe not so a bit more boring part, but it helps to understand the complexity of the product specification. So it is, in a way, it is a simple product specification in terms of interaction, but it is very complex, built, designed with a lot of relations and between the defined features and attributes and information types. So the main things are that there are feature types with geographical geometry, and then there is an information types which are describing a lot of information which can be used and reused for 1 or 2 or 5 or all of the features are added. So it's not needed to be encoded many times. You add the right information, you build the information type object, which is like contacts, for example, and then that is how you can add it to all of the port these features. It is an inheritance type model, so it has defined again attributes which are to any of this feature type necessary to be added or could be added, and they are reused. So again, they are in that way simpler, and then there are specific attributes which are for specific features more. And information type the same, so you define one more generic attributes, and then there is a specific. This is more interesting now to this type of the port information, because it's nautical information is a separate any information, very flexible, regulations, restrictions, or for example, available port services, applicability of service hours, and contact details, authority. All that is defined as a specific information features. Then how it all works together is by associating things like information to a feature. Again, here, for example, available port services example, it can be associated to these types of the features, and there are reasoning behind it that it's not associated, for example, to everything, but to these ones. It reduces the model if it's not associated to everything, but it's the port information manual has been taken as a basis to again understand and which would be the necessity to be linked. Some other examples of associations. So again, easier is when the common attributes of any feature is linked to a information features, and then you define these levels of which amount of information needs to have an information type feature attached to it. It can be also very complex, but again, it has been taken into account as it is described, or as it's been used or should be used. This one is interesting because it's applicability. So, and here you also see the vessel description. It's in simple and complex attributes. The thing with this is that it is as flexible build as possible to be able to encode any or describe any ship to apply to a regulation or to exclude, for example, to a specific regulation. So you build a feature which is an area, you apply to it some information and attributes to this area, like a restriction. Then you add an information type which describes that restriction in very detail. And then you add an information about the vessels which are either included or excluded of that particular regulation. So and that all is in a background. It is complex, but in a tool and in the when the tool is built, it is actually simple, and this complexity gives a flexibility. And all that, what you see here in the models, is then defined in a feature catalog. And that was what Sven Chavalan was mentioning about S100. So nothing of this one is kind of overriding S100 main implementation. It only restricts further down, but it's not overriding. So it is that flexible. So it can be, and at any time, a simple attribute can be added if it's not overriding the S100, or any attachment or any association can be created, and it will instantly work in any EGDIS. Again, taking the port instructions manual, so there has been associations built between the features as such, and when it's visible graphically, like you see in the top right, then it's also the how it's built in the model. So that is again, once it's built, then it helps you to avoid mistakes by linking wrong feature to a wrong feature. Some feature type examples, maybe not going to detail into this one. And some information type regulations. Yes, that is one. Also, a good part of this standard was thought that the regulations should be a part of this port information. Contact details, complex attribute. So a lot that can be added to the specific level of the feature types. And one interesting thing also, what maybe is not always considered, is that the because it's a geographical information, it has to have a spatial quality to it as well attached. So that is a part of any geometry has to be defined with a spatial quality, and standard mentions a particular threshold of that spatial quality information. And one, again, enabling machine readability and harmonization is that most of the attributes are code lists. So there's very few of trying to be used as a textual description. So all is a code list. And again, that is where, again, I urge this group to look into S131 and through the code lists, attributes and code lists of the attributes. If that is enough, for example, for this standard, what you consider needs to be as a minimum requirement and so on and so forth, is it at least optional in these code lists already included, or it should be included for the further development? Testbed. So more interesting bit now. There has been this a slide, also a stolen slide from the DYNAPORT, and it says that digital testbed or public software is needed. And ta-da, here you go. I have already since this year is the Marine Harbor Infrastructure Database created. Again, the background of it was that the port authority is not always the owner, or the hydrographic is not always aware of information. So there is a built web tool, and it should facilitate the information exchange. This is how it would look like. And the IHO lab was taking this project on to create a user interface, database, and the connection to it. It is a IHO Singapore Innovation Technology Lab project. There's a link you can follow and read about that. It creates the S131 database infrastructure and the database itself. It facilitates the exchange of information between harbors, HOs, and port users. So get the user account into that database and get the specific rights to either edit or create a new database for a specific port. It supports the creation of S131, so you don't need any other tool to, once you have added all the information, you can export S131. And again, based on what Sven Schäverlund mentioned, because it's an official product, once you go through the IHO and obtain the producer code, so as a port, for example, then you as a port can issue an official S131. It's not necessarily need to be a hydrographic office. If you are responsible for your maybe terminal, you can also issue actually your terminal's S131. So that is if you are certified and approved as a producer of official product, then you can issue this official product. Yeah, and that was the point is that it should be a collective responsibility to create the official data. Who worked on it is the IHO lab. Then the backend was IIC Technologies, who created the tools, and the interface was created by National Taiwan Ocean University ENC Center. And Portland Sciences feature catalog created, so helped to set up that XML file. And hydrographic officers who really wanted to try to create these data sets for the ports. This was the idea, to have a port database and from different files or from manual input to have an editor, web-based editor, and be able to export S131 and their support files. That is how it looks when it's actually done now and finalized for a wider testing. The port database, it's already linked to an official port Unicode database, SMTG, and ISPS port facility database. So that is when you open actually your, for example, this is Kristiansand's harbor. That is what you would already see without adding any data at all. Yeah, as I mentioned, these three databases are already connected, and there could be some potentially others as agreed or required for testing. So the functionality of this port database is, first you should be a registered user. So now it's a bit simpler when it's a project, but it might be some administrative, someone who would administer, who is the official producer. So you can get access to the data and can produce the data that you are authorized to produce. Simple layout, adding or creating specific ports, uploading or exporting this S131 dataset. And yeah, then the resources that I mentioned are already officially available, and then the resources you create yourself. It has the overview, so you see what is the layout. You see all the features and their tree, all the attributes. You can create the associations to 1 or 10 or all the port you created features. It helps you to well, it shows you only the relevant attributes you can code for a specific chosen type of the feature. So avoiding all the complexity, understanding all the complexity of the model, it just shows you what you can do with a particular feature. And it gives you some tools, basic tools to like measure distance and angle for birth, for example. Challenges some identified earlier was that identity management. So is it maritime connectivity platform, or who is the authority? And establishing a good information flow between ports and hydrographic offices, and IHO has encouraged hydrographic offices in each country to be the one who is responsible for at least being aware and approving the producer of any S100 data which is related to the navigation. And yes, one more thing that maybe Svein Schauland mentioned, that is all this navigational. It's S100 actually can be also non-navigational. So if you create a product specification which is compatible with S100, this and this version, but it is not intended for EGDIS ever. So you don't necessarily need to follow, for example, EGDIS specific rules. It can be just a product specification which never ends up in EGDIS. That is a good thing as well for S100 implementation. Yes, ports and terminals, operators, source providers, who is who and how to contact them, how to find them and maintain them afterwards. What would be the rule sets, and perhaps exactly this standard you are working on could be the one who is actually helping to make this administrative part of it, how to find the relevant S131 producer in a port or in a hydrographic office or in a country. And how it should then be managed, who is responsible for these data sets. Underway annex. So now, because the tool is available, you can populate it. The testing of the data model, now it's 1.1. Port users adding the data, or the test users adding the data, exporting and packaging them in exchange sets for EGDIS or for PPU units, testing for that on top of S101 NC, new ENCs. Port feedback, so hopefully they send it's really great or it's really bad, and then or we missed this one and that one and could be better. So it's in a development now. It's great chance to see this, how it S131 practically actually works and can be created. And of course, then once you have S131, it's also possible then to share it through either the RENCs, regional electronic navigational centers, or from the ports themselves, or from IHO and so on. And the thing is that they also at the moment is still to be discussed, of course, but it is a GitHub code, GitHub repository where it's maintained and built. So, and it's IHO owned, so it hopefully is still always available as a free tool then for the future as well. And questions, discussions, some additional resources. Yes, please. This was, I believe it was earlier presentation of S131 for this group. So this is extended after that. Port.net, this is the link to the tool, the S131 project tool. And this is the IHO registry, as Svein Schauland was talking about, where the official published S131 marine harbor infrastructure documentation, and feature catalog and portrait catalog can be obtained and looked at and understand how it works all together. Yeah, thank you very much.
Thank you, Mikus. Before I hand the word over to Jon Morten, Jaco had some questions, quite specific questions to the portdata.net. Mikus, you can have a look in the Q&A and maybe answer directly there. Otherwise, we'll address that in the Q&A session at the end. So, finally, Senior Engineer Jon Morten Klingsheim at Kystverket, or the Norwegian Coastal Administration, will discuss S421. Jon Morten is responsible for initiatives in e-navigation and maritime ITS. He established, for example, routinfo.no, which is a national e-navigation service, and lifted the e-navigation service on wave forecast for Norway from a pilot level to a national service. He contributes to digital standardization on a nautical and international level, and he has a special interest in geospatial information to be utilized for smart intermodal transport. So, Jon Morten, with that, you're up, please.
Yes, thank you. That was a long introduction. Thank you. Yeah, so my name is Jon Morten Klingsheim. I will present what is the S421 and what's going on there. I think you can see my screen. I hope so. It's S421 as an international enabler established by IEC, and this is a bit important as it's IEC and not the other like IHO and other standardization organizations. And it will be about ship and shore communication to the value that now this information can be shared. Yeah. Oh, let's see if I can get moving. Yeah. So a main reason for establishing this route standard S421 is that the information can now be handled, or it's enabling the information to be handled in different domains, in different systems. So here shown by the ECDIS, which is the basis where the planning of the voyage is happening. But you also have other tools like planning stations or weather optimization. Other tools can deal with this. Portable pilot unit. So also the pilot being a part of the bridge crew can handle the same information as the ECDIS. And then on the right side here, the VTS operator. So in a way, bringing different partners together and then sharing main information about the voyage. In very many sketches also, Svein showed some maybe on this e-navigation progress coming with all this new products. A lot of information is becoming digital. And what should we bring in? What should we take? It's many different standards, many different products, and it's a major value that there it comes. There is a big value of including the route which the ship is going, because that will assist on telling which information is of interest for the navigator, for the ship, or eventually other partners involved in the shipping. So bringing this S421, the route plan, into the digital information, it makes a lot of new opportunities to get the information relevant. So you have the time and you have the waypoints it's going, and then you know which elements can be relevant. A bit more text. The background for the route, or the route plan, which for those in semantics are interested, the route plan is the terminology. It was established in 2015 already with the RTZ format, which is in a way the first baby, and the S421 is the next. And that was established in 2015 and also implemented in 2016, that this should be possible to exchange routes between ships, between the ectis. Then bringing in this S100 framework, it's established S421, which is a further development on the route plan. And now IMO decided that in the ectis, the S421 will be chosen as the standard to exchange a route. The RTZ will live on, but mandatory. So the S421 has to be implemented in new systems, and there will be amendments to the resolution telling on the ectis performance, at least if that is approved. So then all ectises will have referring to these technical specifications. The ectis from 2026 as the earliest, but by 2029 all ectis systems should support the new format. So RTZ today, but S421 is coming, and yeah, it will enable a lot of more. What is important, very much important to understand, is when you exchange the route, you might not exchange all information in the ectis or a route planner given by the red area here. You're sending a route plan with and you establish the ID when you're sending it, but you might have more information in the planner or in the ectis. And then it can also go the other way from any shore partner, from a port or from a VTS like we have in the Coast Administration, or any other service, ice navigation or others. You can respond with a route eventually. You can also respond with other information, but you can also respond to send a route to the ship. What's quite important is now in the work with this ectis performance standard, it's to be aware of that it's the mariner who's responsible for the route plan and has to take the responsibility. So in a digital way, when a route is coming from outside the ship, it's handled that very much that this is not my route. It's for voyage planning purposes only, and then the navigator has to accept and then bring it in his way to be a route. And of course, this is also of importance when you see the red area, which he could have a lot of other information connected to his route. It can also be like sending maybe the route only the part within a VTS area. It could be only the part from the pilot boarding point, or it could actually also be two alternative routes. So yeah, so it's important to keep it that the ship is responsible part, because the route is and what is used when you navigate, and being responsible for that. So also some technical here in the schema and the information elements for the route plan. So I said that the terminology S421 is a route plan. Main element is a route with a name. And actually, the name, if you see, is put to the right here. There's a lot of information you can add on about the route. And that's here in a route info element. There's a route name and many other elements. To the left side here, waypoints, of course, the main element with the geometry, and also connected to the leg, because a waypoint tells I'm going to this next waypoint, but it's the leg that you're sailing, the distance to get to the next waypoint. So some information is on the waypoint and some on the waypoint leg. There's also a name on the waypoint, and here is course of a ground. Here is many different elements. I might come back to some of them. The schedule is connected to the waypoints, so you add also schedule. You don't have to, but of course, if you're planning a voyage, you will quite soon bring in also the time schedule, the ETA, and that's connected to all the waypoints. So you will have a time on each waypoint, and that can be calculated different ways in the ECDIS, by speed, telling the speed, or by telling what time to be in the port or leaving the port. So it's calculated time on each waypoint. And a new element coming in now with S421, which was not in the previous standard, is this action point. I guess it's small letters, but you can see it on the file afterwards. But it's important to see that this is the blue line. It's not connected to the waypoints, which is for navigation. So it's a separate separate element with their own geometry, which with a position or a line, or actually, and you can have an action. What should you do at this point before entering the port, or before entering an area, or any kind of action for navigator? Which my impression is that previous in the ECDIS, navigators have used the waypoint for this. So now there's a new element coming in. On the action point, there is a required action, and you can say a time before, 2 hours before, or a distance, 2 nautical miles before. Or and today there are some specific actions presented, like reporting. So then you will know that at this point, some time before or some distance before, you should report. Also, if you go back to the route information, there is also included the port your departure or the port your arrival. There are 2 IDs. So the first one is connected to UN low code. The second one is free to use for any ID that could be a name, it could be another ID eventually, but the ID number 1 is connected to the UN low code. Yeah, I'll go for next. So I can bring it up again later if there is any issues. S421 standard shows a lot of possible use cases. We have mainly had we are using the RT set now in a way where we are going to bring in the S421 as soon as possible. But as of now, we have this a reference route that we are publishing out for to bring in on a vessel, and also testing it a bit on the VTS on route cross check, which is here. The route plan standard is a version 1.0. It's very different. It differs from the IHO. This is a standard from IEC, and even though today is version 1.0, it's operational, so it's open to be used in operation. There is some activity now in this working group responsible for I421, and the plan is within the year to have some minor changes. It's not very much, but there will be some to be made before then the performance standard on the ECDIS then after this can refer to it. So the version 1.1 will be the operational when the first ECDIS comes to support this. But it's not only the ECDIS, also a lot of other systems can support and utilize the S421. I think I'll jump a bit. I can mention the warning, a new category. I don't know if you noticed there was actions that if you're sending a route, you could have an action point with the warning category. So because that will be important to this is not just a note, it's important warning. Together with this coming up with version 1.1, the work group has also chose to make a supporting document, because IEC is also differing in IHO in other means, and it's the business model of IEC is that you have to pay for the standard. It's not open, free, available. Just like ISO standards and IEC standards, you have to buy the standards. So because of the exchange of information and the need for also other systems to be aware of this, and for the mariners, it's bringing in quite a few new changes. It's suggested to make a supporting document with some use cases. As of to now, it's including how route can be a part or intervene with nautical publications. Two further subjects are search and rescue, how route plan should be as a best practice handled by the mariner, and eventually also shore reporting is discussed. How route plan can be an element. I'll just go quickly. This is the coastal administration in Norway have a service today with routes, reference routes, which are quality assured by the pilots, together with the VTS and its navigation service and pilot exemption certificate unit. So we have now several years with experience with exchanging route from shore to the ship. One of the main values with exchanging routes is that you can add information. You mentioned also in the port, you mentioned that regulations are relevant, but also along the route. There are a lot of regulations that's not easily accessible today. So here, if there is a ban on passing, which at least in Norway on the Norwegian coast, there is for larger vessels, you have to look into quite difficult regulations and texts and pictures, and it's not easily available. And partly it's also not, it's updated of course, in the legal papers in Norwegian, but most mariners would like to have it in English. On the land sea, you can just get a sign when you drive there that you're not allowed to pass. but on sea, the regulations are quite more complicated. So bringing in this as connected to the route, that if you are sailing this route, you can access this, we think, by the action points of the route, and then connected to this information element to the left here, a part of the regulation, which could be a part of a nautical publication. So instead of looking through all possible information elements which are coming up now in the S100 world, by connecting it with the action point, you hold the information on for this specific voyage. We are doing some of this on the reference routes from the coastal administration, but also the ship itself could be doing, of course, this when information elements are on the ship. I think I should jump a bit. We have established API for these reference routes, and here are two red small issues which are quite important, which are not solved in the old standard. So I'm very happy that now the S421, with the route number, that there is a unique ID to be handling it, and also that the low code here, or the destination of a route, can be included in a route, which is not possible in the old format. And there's a further a lot of elements which makes it much better for machine-to-machine reading, that the machine can understand what's coming. Test bed, we have a minor test bed in the ISDS project. It's not a full data model like mentioned on the port data. We have established a tool to make S421 files based on an RT set input to also push for test beds to establish possible. So you can bring it from the ECDIS, or you can bring it from the PPU you see left here, from the pilot unit or from the VTS, and then establish 421 files for testing, which in a way there's not many who have tested the format yet. So we are trying to push, make that available. Here is the tool shown, the website here, S421 Creator. It's ECC. We have established this minor tool, but by bringing in an RT set and then add action points, because the RT set does not have. It's like here going to Oslo, you see AP1, AP2, AP3, which here you bring in action points, which can be called the pilot to confirm you have you will come there at the time you have said and want the pilot service. It can be to a regulation. Number 5 here is a regulation, and has suggested to use the MRN to unique IDs. I'll push it a bit. The value of this external reference is high, very much, because also when digital exchange on the maritime domain with VDES is one tool that is on the run or on ongoing testing with, the bandwidth is an issue, and you shouldn't send all data again and again. So if you have a nautical publication on board, the route can just give reference to which elements by using the action points. And this opens for to give the navigator information he should have, but you don't need to send all of it. You give reference to the element. So this is how also the S421 will be working very much together with port information or other information, the regulations and yep. I'll have this for discussion eventually. It's there's a lot of use cases for the value to bring information from the ship, what it actually is, how it's sailing, the schedule, the ETA, and the elements connected to the route. So yeah, for anyone to respond to. We also have a digital twin environment, which we have now brought in the RT set, but we can also use S421 in the future to test that actually navigators, the pilots, eventually other involved can see and test to how this will be in different cases. So taking a bit time, but that was running through the S421 route plan and that element. So I'll hand it over to. So thank you.
Thank you, Jon Morten. Yeah, so we have 3 minutes left on our scheduled time for questions and discussions, so let's be efficient. There are some questions on the portdata.net service, which has been answered and discussed in the chat, so I will not dwell into that. So if other people are curious, you can see the questions and answer in the Q&A. I'll start with the first question first then, from Jaco, who first starts by asking about forgiveness for his ignorance on of S100 capabilities, but that's why we have this webinar today, so all is forgiven, I guess. For just in time, Jaco writes, we have started to talk about port passage planning areas. Would this area be something that would be able to be communicated using S100?
Or one of the other ones that were just presented, by the way. So
yeah, one of the S100 specification.
I can try to give an answer. I'm not myself familiar with what the port passage planning area actually is, but in general, I would say that, you know, if it is an area that contains valuable information for navigation or marine operations, for example, within a harbor area, it could probably be proposed for inclusion into the S131 data model. If such areas are not only situated within harbor areas, perhaps they should go into other S100 product specifications, S101 perhaps, or some others. But I guess there is absolutely a potential for expanding and on what can go into and be covered by S100. And I guess the best way to move forward with such a request would be to try to describe what the use case of this type of planning areas would be, and the importance of it being available in geographical data sets created on the S100 data model. So it's just see this as a general comment from me. Apologies for not being familiar with the definition of this area. Thanks.
no problem, Sven. I think this is sufficient for now. With this, we can follow up also from ITPCO to see if and when we need to do this sort of push for it to be included, and also find the right standard for it.
Thank you, Sven, and thank you, Jaco, for the comment there. Marianne is saying thank you for great presentations. I echo that. She writes, regarding the S131 testbed project, have you looked into how this relates to the Norwegian SKFB Havnedata system holding asset information for several Norwegian ports? And she writes in parentheses, though not in S131 format.
Yes, I can answer that. There has been a project which looks into how the conversion of the Havnedata base could be achieved and what is the similarities going there. What I can tell that although it always is built on a good intentions and on the cooperation with the actual actors, but it not necessarily is easy, the conversion. For the routes, I guess it was a bit more straightforward. The converter from FTZ to because it's a standard to the standard, but for the ports, there is more work to do. Especially when it comes to the terms and terminology. That is the most difficult part, where things are called differently. So that's why the S100 has introduced the GI registry, where where all the concepts first are registered. Then the concepts can be used as an attribute or as an object, and so basically built from there. To achieve what you need, build your own dictionary, and out of the dictionary you build the project specification. That's how it is intended that I built this 100, and that's why it is compatible with and becomes compatible with a lot of other things. You can join and work together then. But yes, the conversion is a challenge, and it has been looked at. There has been there is a proposal, so achieved in a way, but yes, it is quite a long stretch to get this easy and running, but it's possible.
Thank you, Mikus. So final question from Jaco here. Jaco, you might want to just jump in and ask it yourself if you'd like.
Yeah, I think this is the question about the, let's say, identification around UN low codes. So in this route information, UN low code is really just a very large area. So NLRTM, if I just look at what that covers, there is lots of, let's say, locations included, many berths, many terminals, many types of terminals, pilot boarding station, a whole range of different things. So in and of itself, the UN low code would not be very informative for the routes into Port of Rotterdam. So my comment was we probably need something a little bit more granular than that as well, next to the UN low codes. So what is available if you cannot use the UN low code as a sufficiently precise means to identify the location?
I can add a short comment. It's not much tested, so it's interesting what will be the response by using this. But you should also not forget that the route actually have the waypoint where it's ending. So you have the position where the route is ending or starting. So you have the position. Yeah.
Great,
Thank you.
thanks.
Yeah, and thank you, Jon Morten, for the last comment there. I think that's all the time we have. 5 minutes over. I hope everyone learned some things today. I did at least. I will export the recording and add all the presentations and from both this week and our ISO 20005 webinar from last week and send it out to you as soon as possible. So with that, I thank you for your attention, and once again, use the QR code here or the link in the pinned Q&A chat to register for our Maritime ITS webinar on May 24th. Thank you, and have a nice day.
Thank you.
Thank you. Bye-bye.
Thank you.
Register done. Thank you. Bye-bye.
Thank you. Bye.
Bye-bye.
Thank you.